Thanks, everyone. Again, I'm James Guler, More Engineering, and I was asked to come here and talk a little bit about a project we have going on down in the Bois-de-Sioux Watershed District, the Lake Traverse Water Quality Improvement Project. There we go. Again, I only have 10 minutes, so I'll try to keep this relatively short, but just touch on the goals, the background, some of the design elements of the project, and the progress so far, and then acknowledge the funding partners and some of the collaboration that happened. So this project is located down in the Bois-de-Sioux River, which is the most upstream portion of the Red River Valley. As you can see in this map, we're located way on the southern end in Traverse County. And the terrain in this area is relatively flat, high terrain. But as you get closer to Lake Traverse, you have a lot of fall in that last 2 miles down into the glacial river Warren. So in this area, our goal is to minimize erosion in section 14, 23, and 24 by stabilizing an existing legal ditch system, Traverse County Ditch 52, that has experienced a large amount of erosion. So the Ditch 52 system, as you can see on the right, it has a 20.8 square mile watershed. Approximately 20 linear miles of ditch were constructed back in 1950, 1951. And the purpose of the ditch system was to basically drain a lot of low-lying pockets of water and some good farmland. And their plan at that time was to take that 20.8 square miles and bring it straight to a natural ravine and into Lake Traverse. Additionally, there's 11.6 square miles that was not channelized, but just naturally made its way to Lake Traverse, and then they connected it to the Traverse County Ditch 52 system at the outlet. But what's been occurring since then is where they connected to that natural ravine, all that additional flow has caused the channel in the last 2 miles to downcut and the side slopes to fail, and all that sediment has been transported out into Lake Traverse. I got this clip here from 1984 because I'll kind of get into the history of it in a bit, but just looking a little bit more at the profile of the ditch, you can see in the last 2 miles, we have approximately just over 100 feet of fall. Every heavy line there is 25 feet. And then the upstream 17 miles, it's a very flat, typical Red River Valley ditch. So a little bit more background. This channel was first petitioned and designed back in 1949. And even at that time, the Department of Conservation from the state, they were recommending against this project just due to the deep gradient. And they were foreseeing issues, but they went ahead and constructed in 1951. And basically immediately after, they began to have issues with erosion along the channel. Finally, in the 80s, the Westman, Minnesota Resource Conservation and Development came in, evaluated the channel, looked at doing a project. At that time, the range was 750 to 1.25, and that ties back to that old newspaper article from 1984. Unfortunately, nothing happened at that time due to the cost. Fast forward to the mid-90s, and then the NRCS came in. They had a plan. Again, nothing happened due to the cost. Keep going to the late 2000s, 2010 or so. NRCS got involved again. Unfortunately, nothing happened due to the cost. So it had a long history of entities coming in and studying it. However, nothing was really coming to fruition. Finally, in 2014, the NRCS and the Bois-de-Sioux Watershed finished up a project team summary. And then the Bois-de-Sioux Watershed District carried that and developed a plan, the Walls-Windsor Watershed Improvement Plan. And we use that to look at different alternatives to address the channel, to mitigate flows to this deep ravine. Really didn't get a lot of traction as far as some of the alternatives. Really the only thing they wanted to see was addressing the channel. So finally in 2019, the Bois-de-Sioux created a local water management district to account for the local funding and began construction after that. The approach was pretty straightforward. We wanted to split this project into manageable phases. We wanted to work with permitting entities to come up with a plan that addressed not only the ditch needs, but also there was some aquatic habitats and connectivity impairments with the DNR. And we wanted to come up with a funding plan to get as much outside funding as possible to minimize the burden on the local landowners. So we split this project into 3 phases, 1, 2, and 3, with phase 1 being the outlet into Lake Traverse, phase 2 being a portion along State Highway 27, and then phase 3 being up into section 24 through the ravine. And just to give you a sense of scale, I had quite a few more pictures, but I cut a lot out this morning, just knowing the 10-minute timeline. But that's me up there in section 24. You can see in this particular area, the channel has downcut approximately 18 feet. And as it's downcut, the side slopes fail and everything just gets washed down that channel into Lake Traverse. So moving on with the progress, since 2019, we really were successful in our project goals. We worked with the Minnesota DNR heavily on the design of phase 1 and 2, and now in the progress of phase 3. I'll get into the design elements, but we've also been able to get outside funding very successfully to the tune of 100% of these phase 1 and phase 2 were covered. And as of this fall, phase 2 is substantially complete. So we had phase 1 and 2 wrapped up, and we're moving on to phase 3. And the design that we tried to follow, I mean, really we had 2 goals. We needed to stabilize the failing channel banks, and how we accomplished that was by simply widening the channel, laying back those slopes. We didn't plan to fill a channel, but then we needed to ensure that any work we do on the side slopes, wasn't affected by future down cutting. So the next thing we had to do was stabilize the channel bottom and reduce future down cutting. And our approach at that was to create a series of steps of pools and riffles. And in the pool, we can control the velocities with high water. And then the riffles, that's where we would target with our armoring and control the velocities. And we went back and forth on how we were going to accomplish this. We looked at sheet pile, and ultimately just working back and forth the DNR, it was decided that we need to do something that improves hydraulic habitat, improves connectivity, while still maintaining our goal, which is stabilizing the channel. And what we ended up doing was, for every drop that I have shown here, this is just an example of phase 2, we did a series of boulder riffles. So you had 5-foot boulder riffles in junction, with about 8 of them in a row, and that would be a single riffle. We constructed about 14 of these in the first phase 1 and phase 2. So digging into this design, this was something we needed to verify the velocity. So I developed a very detailed 2D hydraulic model to look at how the velocities would behave over each boulder weir, and using that to identify, where we need our riprap extents through phase 2 and phase 1, and now into phase 3. I have several construction photos. Just you can't get a sense from the scale here, but every boulder there is about 5 feet across. So construction in progress on phase 1. Again, you can see the scale relative to the excavator, the dozer on the side. Through here, that's the drop. That's the roughly a 3-foot drop across the riffle, and then you have a flat pool until the next riffle. Several shots in action, and then up into phase 2. And I don't know if I have this as a video, if you can hit play on that, but if not, it's okay. Basically, it's just showing how the riffles behave under a flow, showing that habitat that was created and the connectivity along the whole channel. So kind of bringing that impairment and improving that. Basically, we wanted to acknowledge all the collaboration that occurred in this project between the Bois de Sioux Watershed District and staff, local landowners that have been really pushing for something to happen for going back to those mid-'80s when you had the Westman RC&D planning their project. Thanks to the DNR and the Army Corps of Engineers for their collaboration on the design, NRCS, and then also the funding of this project. Phase 1 and 2 are complete. The total for these 2 phases was $1.65 million. And these phases were 100% funded by outside sources other than the local water management district. Thank you. So the big funding partners were Bowser, the Clean Water Fund, the PMP grant. We were successful in phase 1 and phase 2. Red River Watershed Management Board water quality grants, both phase 1 and phase 2. The Boyd Sioux themselves kicked in for both phases, and then the Traverse County SWCD, they partnered both with funding and they aided in the design, and they actually helped with some seeding along the buffer, some native seeding in there. So partnered in kind to complete the construction. And then the Water Management District, again, so far their cost has been 0, but looking to phase 3, much larger effort, much more to come. So again, that's currently in development, and we're working on the funding package for that, for the phase 3 portion, which up in this area again has experienced the most severe erosion. Currently, the Bowser Clean Water Fund has come through with their PMP grant again for the 3rd time, so that's a success. And ideally, we will be moving dirt on phase 3 come fall of 2022. So